Before we graph exponential functions, it's very nice to know the domain and the range of the function. That way we have an idea of where this graph should even be going. Off to the right, we can see the function y equals -3 times 1/4 raised to the x plus 1. What we want to be able to do with this function right now is identify the domain, which represents all the x values, and the range, which represents all the y values. As we look over to the left here, this is a graph of the function, and we can see that on the right side it looks fairly flat. And the reason for that is because of a horizontal asymptote. And that asymptote is at the line y is equal to 1. Now in the equation itself, we can see where that asymptote is by looking over here at the very end, this plus 1. So this is where our horizontal asymptote is going to be. And the nice thing about this is it allows us to see where that boundary is. And in this case, it's going to be that upper boundary. And with it being an upper boundary, I know that that's going to affect the range. So I'm going to come down here to the range and say that my highest value in my range is going to be 1. And if I wanted to know the lowest value, looking at the graph, I can tell that the graph is going down forever. It's never going to stop. And I can come over here, and the further I go, it's just going to keep going and going and going. And how we represent that is with an infinity sign. So with the range, the lowest I go is -infinity. So the range is from -infinity to +1, the smallest y value to the largest y value. Now if we look at the domain, on the left side, this graph continues to go on and on forever. On the right side, it does the exact same thing. So with these exponential functions, we can see that the domain is going to be infinite both ways. So I'm going to represent that as -infinity to +infinity, or in other words, all real numbers. So the domain represents x's left and right. The range represents our y values from bottom to top. Now let's take a look at a second function here. I'm going to come up here and write another function. The function y equals 4 times 2 raised to the x plus 3. I'm going to come over to our graph here and change our function so we can see this new one. So y equals 4 times 2 raised to the x power plus 3. So notice this one's quite a bit higher up on the graph than the previous one was. And the reason being, if we come back over to our equation, is because of the plus 3 on the end here. So the plus 3, instead of shifting it down like the previous problem, is going to shift us up. And that also corresponds with our horizontal asymptote. So I'm going to come down here and represent the range. And that range, instead of ending at 3, is actually going to start at 3 because that's now our lowest value. And as we look at the graph, that's going to go off to +infinity. If I want to talk about the domain, though, the domain describes all of our x values on the graph. And again, there's no restriction on this graph going left to right. The left side continues to go on forever. The right side continues to go on forever. So I'm going to represent that domain as -infinity to +infinity. Now the nice thing about exponential functions in their basic form like this, we're always going to have domains of all real numbers. What allows us to determine the range is a combination of the asymptote, which in this case was at +3, and our coefficient out here, the 4. Since this 4 was positive, we can tell that our graph is above the horizontal asymptote. That's why 3 is the lowest value in the range, and it goes to infinity. Whereas if we come back to our original function that we did, the +1, it still shifted us up, but then the 3 in front, this -3, tells us that we're going to be below the asymptote, which is why 1 was the largest value in the range, and then it went to -infinity instead of positive.